everyone. Today we're going to learn about graphing a quadratic using what's called the vertex form. Vertex form looks like this. Y equals a parentheses x minus h squared plus k. Now that's just a general formula, so it will look kind of like this. Let's take a look at a problem that actually is in vertex form. Oops, my bad. There we go. This is in vertex form. How do I know it's in vertex form? Because it has parentheses, x plus or minus a number, squared, and then plus some other number. That is a vertex form. Now this is a great way to find out your vertex without having to do any extra work. We know, because there's always this pattern, this number here and this number here create the vertex if this is in vertex form. So the vertex, we simply go ahead and make the opposite of this. Quiet. That's my dog getting mad at the other dog. Hey, Coco. Anyway, I'm so sorry. We have -2, because it's always opposite, and we have 3. So that is our vertex form. And the negative out in front will tell you that it reflects over the x-axis. Now we can always create a table to create the extra points that we need to create the parabola, but this will be our vertex, and this tells us it reflects. Let's take a look at what it looks like. And so we have our vertex is over 2 up 3, -2 up 3, and it does reflect over the x-axis, and it's opening down. All right, let's take a look at another question. This is in vertex form, so it makes it so easy to get your vertex. The numbers are right here and here, and remember it's always opposite of this one. So if it says +1, my vertex, I'm so sorry, this is not working so well. My vertex is going to be at -1 right here, and this is my y value, -1. And then it's a +1, so this will open up, and we can go ahead and plug in and get an x, y table going if we need to graph. Well, let's just go ahead and take a shortcut and take a look what it looks like. So if we put in the -1, -1, we couldn't put in a -2, we would get 0. Put in a -3, we get 3. And we could do the same thing on the other side. We've been doing that for a while now, so I don't see the point in taking extra time to show that part. The key to understanding this is making sure you know how to get your vertex. All right, let's take a look at something that is not in vertex form. Can we create vertex form out of this question? We can by what's called completing the square. Now, so what we do is we will complete the square. And how do you do that? You have your regular problem. Now we're going to separate that +11 out. Okay? So what's half of 8? 4. And we're supposed to square it. So we write 16 right here, right? And the 16 over on this side. Now, what else do we have to do? Well, we have to identify, there's the 16 and the 16. We have to go ahead and put these two numbers together. So we will get, oh, I'm so sorry. No, we do not have to put them together. We have y plus 16 over here equals, and then this part, of course, we have our x, and this is our 4, and the minus sign makes sure that this is a minus sign in between, and we have +11. So now all we have to do is move the 16 over, and it will be in vertex form. Subtract 16, you get a -5. This is vertex form, so immediately I know what the vertex is. Take a look, and you guys think about it for a moment. What do you think the vertex is? If you wrote 4, -5 for your vertex, you are correct. That is your vertex. This will open up because in front of the x you see a positive. All right. Now, we could graph it. We could create our xy table, substituting in x and getting y's out. And it would create this beautiful parabola here. And so if we had 4, -5, I would choose 3. And then I would probably choose 2, honestly. If they chose to do a 1, it wound up here. It doesn't really matter as long as you pick 2 more points on this side and make it symmetrical. All right. Oh, here we go again. We have to change this to vertex form. If we want to change that to vertex form, we are going to have to complete the square. So let's try that one more time. And we have y equals x squared minus 6x And we have a plus 5, but we'll write it way down here. What's half of 6? 3, and you're supposed to square it, so you put plus 9. Now, if you put plus 9 on this side, you're going to have to do it on this side. So we have to have plus a 9. Now, let's take a look at this. We have y plus 9. I wrote it wrong last time, but that's okay. In here, we should have x. This is a minus sign. Square root of that is 3 squared. Now, we also have the positive 9 and the positive 5. Oops, we already took care of this. So sorry. We have a positive 5 over here, right? So, this part here simplifies to x minus 3 squared. Square root of x is x, square root of 9 is 3. This minus sign goes down, in case you forgot. Now, see this positive sign? We need to have just a y equals here. So, minus your 9, minus your 9. Y equals x minus 3 quantity squared, and this part becomes a minus 4. So my vertex is very easy to identify because now it is in vertex form. So my vertex should be opposite of this, so we write 3 and negative 4. And we could do x and y. We could do a table. And we could put negative 4, or I'm sorry, 3 is the x value. And we get negative 4 out. And I would take numbers to the left of it, so 2. And I could put in 0, just for fun. So, if I put 2 into this problem, 2 minus 3 is negative 1. Negative 1 squared is 1. 1 minus 4 is negative 3. Put a 0 in here, 0 minus 3. Negative 3 times negative 3 is 9. 9 minus 4 is 5. And so when you graph it, it will look, let's move this stuff over. And so we've got, oh, my mistake. 3, negative 6 is your, no, I did not make a mistake. They made a mistake. It should be 3, negative 4 is your vertex. So, I'm sorry, the graph that they show here is incorrect. So we will have to go with what I have here, and the graph should be symmetrical on the other side. Sorry for the mistake on here. I can't blame myself because the book made this mistake. The vertex should be 3, negative 4. We are correct down here. All right, see you guys tomorrow.